Hello, everyone. I'm making a recording for quiz number 5 because there are some questions about that quiz. And so I'm going to share the screen with you. Okay, this is the first question, the second question. I'm going to go over all of them. So let's get started. The first two questions, okay, the first two questions. And I'm going to share the screen with you on the other page, right? These are true false questions, okay? The first one, before I tell you the answer, okay, I'm sure you have some ideas of how you have answered that question, right? Mathematically, well, we know that this is a statement. This is a statement. And this other one is also a statement. What does it say, right? What it means? Well, when we look at the left-hand side, right? The left-hand side, are they the same or they are different, right? So when we look at 1 and 2, right? When we look at the 1 and 2, so we'll be asking some of these questions, right? Is root x squared and the other one, the square of root, right? So is this the same as the other, right? Some people have come to me, right? Some people has come to me that saying, hey, of course, this is equals to, the first one is equals to x squared to the power of half. Okay, and so this equals to x squared multiply, right? The multiplication of the exponents, 1/2, right? Where the source is that b raised to the power of m and then raised to the power of n is equals to b raised to the power of m times n. Okay, so that's the property that's being used. So we end up with x raised to the power of 1 because 1/2 times 2 is equals to 1. So that equals to x. Is that right? Number two, that people will argue for the same argument, right? The denominator, well, inside the parentheses is x raised to the power of 1/2. And then raised to the power 2. So we can apply that property one more time, and then we will get x raised to the power of 1/2 and multiply by 2. And that equals to x raised to the power of 1. And that's equals to x. Which one is right? Which one is wrong? Right? Now, I'm going to give you the answer, okay? And I will explain the answer to you. So please listen very carefully, okay? Please listen very carefully. For any real number, x, right? Can you do that? Can you do that? Right? In what circumstances can we do that? Right? All right. Now, before we dive into it, right? Suppose it is true. Okay, suppose. Okay, so I'm leaving these question mark for you. Okay, we'll come back to them. We're going to come back to them. Okay, I would like you to draw the conclusion. Because if I simply tell you it's right or wrong, you get it for this time, and next time, you may still be confused. Okay, so we have to understand. First of all, this is a statement. What does that mean? It means it is true for any real number if it were true. Okay, now, is it true for any real number? We talk about mathematical truths. If true, always true. False once, false. Okay, so I can give you an example because this statement says for any real number it's true, right? So this number I choose is going to be x equals to -1. Okay, so I'm going to replace x by -1 in the place parentheses, and this is a -1, right? Is that true? Is it true? Is it true? Right? So we assume x equals -1 because if it's true, it should be true for any real number, right? So it certainly should be true for -1. And in this case, we will get, okay, so if this were true, right? If this statement okay, is true, then the following should be true, right? If true, always true. However, the left-hand side is equals to the square root, right, of -1 times -1. It's equals to -1 times -1. And that equals to the square root of 1, right? We need to do the multiplication first before we take the root. So we need to do the exponent first. And the square root of 1 is equals to 1. Apparently 1 is not the same as -1, right? 1 is not the same as -1 because the right-hand side is -1. So that's how, right? As a result, right? So if we assume this is true, this is gonna lead us to +1 equals to -1. That's contradict, right? That apparently is wrong. Therefore, this assumption, right? This assumption say this is true, this is not true. So this statement is false. So this statement, because we have a counterexample, okay? Therefore, this statement is false. Okay, therefore this statement is false. Okay, so now we understood this is a false. Okay, next question is, what's the difference? What's the difference between these two? Right? What is the difference? What is the difference? What is the difference? B-R-E-N, okay, between these two. Between. What is the difference between the two? Well, in order to see the difference, okay, in order to see the difference, we need to look at the order of operation. Okay, the order of operation. When we are processing the square root of x squared, okay, what's the difference, right? When we are processing the square root of x squared, the order is that we have x is given, and then we're going to process, whoops. So x is given to x squared. Okay. And then what? After x squared, we're going to take square root. So that's the order of operation. This order, okay, this order determined by this rule combined with order of operation determined that the domain of this rule, x can be any real number. Okay, because any number time itself is going to be non-negative. When we take square root of non-negative numbers, we'll get another real number. Okay, so x can be any real number. Okay, x can be any real number right here. Okay, on the other one, however, okay, what is the order for this guy? Okay, so we're gonna have to do the parentheses first, right? Please excuse my dear Aunt Sally. Okay, so we need to do parentheses first. Inside the parentheses, we have square root of x. So when x is given, we're gonna have to do square root of x first. This requires, right? This step requires, if you go back to see the in the first week, right? When we, first week or second week, when we talk about those functions, right? In our discussion, we talk about domain, range, and this function is discussed. This one is the domain of this function at this point. Okay, so let me put a bracket, right? This domain for square root of x, by doing this step first, we have to require x must be greater than equal to 0. And in this expression, the way we write it, it has implied. Okay, it has implied. So we don't need to specify the domain in this case, because it is implied in the way we write it. Okay, you will see in the future, in this class in the future, a lot of the domains are implicitly, indicated, like in this case, right? So, because only when x is greater than or equal to 0 can allow this operation to continue. And then after we produce the square root of x, right? After that output is produced, and then we can square, and that output, right, for square root of x is going to be, non-negative. So from the outset, this operation requires that x has to be non-negative. So as a result, it's going to be x. Okay, so now let's go back to this operation, right? To these two operations. Which one is right? Which one is wrong? Right? This one is okay. Okay, so this is okay because we agreed with that implication. For the other one, however, is no. Why? Because if you go back to your algebra text, okay, if you go back to your algebra text, when these operations is carried out, there's an attached condition. So even if this is taught, okay, I know this show up in some textbook. So let me write it down. In some algebra text, okay, these do show up. Okay, you do see this. But there is an assumption behind it. That assumption is assumed. Okay, typically in the title of that set of exercise, they will assume x is greater than or equal to 0. So this operation can be done only x is greater than or equal to 0. So if X is negative, that case is not included. I think this might be the reason some of our students are always confused by this. In fact, this is a #1 mistake seen in pre-calculus classes and calculus classes. It's like perpetual mistake. So this is a terrible mistake. It is false. Okay, it is false. So I'm going to check this one. It's false. Okay, false. This is a false statement. When will this be true? Only when X is greater than or equal to 0. But we don't have that condition attached to it. It's that for any real number. Therefore, for any real number, okay, for any real number, it is false. Okay, so now it is only true. It's only true if X is greater than or equal to 0. Okay, go back to see those algebra texts. I know this is awfully confusing. Okay, but what will be right? Right, we know #2 is true, right? #2 is true, we got it, right? So in this case, it is true. So we have that question resolved, right? So this is true. This is true, very good. But is there any statement that says about the absolute value of X equals to what? Okay, this was addressed in our recordings in the previous week. Okay, so I would just go over it again because this is such a perpetual question. Okay, this is such a perpetual question. But anyway, so let's continue. Okay, we know one is right, one it is true. Okay, so let me summarize. Okay, so it is false under the circumstances. Okay, we say it's false. Okay, when is it true? When is this statement? When is this statement true? When is this true? Right? That's our question. We answer that question. So for that statement to be true, X cannot be any real number. X has to be larger than 0 or equal to 0. So this is when it is true. Okay? Now, so for any real number, right? Can this be true? Can this be equals to something that will make it true? Right? What would that be? What would that be? Okay, what would that be? Okay, so here's the discussion. Because the domain, we just talked about the domain for square root of X squared, right? So from the domain is all real numbers. From -infinity to +infinity. Among these numbers, there are a class of positive numbers, negative numbers, and 0. Okay, so we're going to observe. Okay, we observe that when X squared, right? When X is positive or 0, this is equals to X. This is equals to X. Okay, so if X is greater than or equal to 0, this is true, right? You can plug in, say 1, oops, sorry. So if X equals to 1, then this is going to be 1, no problem. If this is a 2, this is 2. Okay, if you have 1.7, and this is going to be 1.7. So for any positive number or 0, that statement is true. So if it's 0, the answer is going to be 0. So you can imagine it's It's true for all the non-negative numbers. But what happens if x is negative, right? What if x is negative? If x is negative, right? If x is negative, what happens? Right? So you're gonna plug in some numbers again, right? So you're gonna try some numbers. Say we tried a -1. We tried a -1 earlier, right? Suppose x is a -1. What do we get? We get +1, right? Okay, so let's go through that step one more time. This is no small matter, guys. Okay, you can easily lose or gain 10, 20 points on these details, on these little details, okay, because they're frequently used fact. So in this case, we will have the square root of a 1, because -1 times -1 is 1. Okay, so that equals what? That equals to +1. So we start with -1, x is -1. We ended up with 1. 1 is opposite of -1. And 1 is also the absolute value of -1, isn't it? Okay. And of course, it is also, so let's just keep this pattern. Okay, I'm going to expand that in the future. Okay. Now, what if it's -2? And the whole thing can be repeated, right? So this is going to be 4. The square root of 4 is 2, right? So this is going to be absolute value of -2. So if x is a negative number, the square root of x squared is going to be the absolute value of -2. So this is x and this is x. Okay, so one is a positive number, right? This is a 4. And of course, 4 is the same as the absolute value of 4. So now you can see, so in general, okay, if x is any real number, okay, x is any real number, okay, the absolute value of x squared is going to be equal to absolute value of x. And this is always true. Okay, so this guy is always true. Okay, for any real number. For any real number x. Okay, so this is always true. Okay, for further discussion about absolute value of x, okay, I believe it's in our first week. So let me give you a pointer. Okay, let me give you a pointer. Okay, I'm giving you a pointer, which absolute value function, right? Properties of absolute value function right here. Okay, did you guys see this? Okay, properties of absolute value function. I want you guys from this point go back to watch that lecture. That lecture talks about, okay, this lecture talks about some of the important properties about absolute value, okay, about absolute value function. Under 2 branches, we had a detailed discussion over there, okay, and the other one you can see square root function and cubic root function that was talked about in regarding number 1 and number 2, okay, regarding domain and range, okay. So you must constantly review these lectures, okay. You cannot say, oh, I'm on week 3, so I can forget about week 1 and week 2. That's not going to work well for you. Okay, that's not going to be good for your grades. Okay, all of these are connected. And I build these lectures and build these lessons the latter lessons has something to do with the previous lessons. That's why they are arranged in these logical order. Okay. All right, without further ado, let's continue this discussion. All right, so let's go back. Okay, so that's number one, number two. The first one is false, the second one is true. Okay, so let's see if I can delete this. So this is true, okay? And this guy is false. Okay, that guy is false. Okay, I cannot delete that one, that other one, okay? Number three, so let's look at number three. What's on number three, right? Let's go back to our quiz number 5. Number 3. What's on number 3? Number 3 says the cubic root. Okay. Is that true or false? Right, so let's go back. So number 3 on quiz number 5 says the cubic root x raised to the power 3 on cubic root, this equals to x. And that is true for any real number x. Is that true or false? Well, we know the domain and range for these functions, which has been discussed in previous weeks, right? And the domain is all real numbers and the range is all real numbers. For x to the power 3, domain and range are all real numbers. And cubic root of anything is domain and range for all real numbers, right? So then you would, if you think out aloud, I would try different numbers. I'll try different numbers for, just as a practice, right? So I can try some positive number, right? Pick some positive number to try. Okay, pick up 0 to try, right? The 3 category of numbers, right? Positive, negatives, 0. Positive, negative, 0. You just try these different categories, right? And you're gonna try as many as you want on your scratch paper, okay, on your scratch paper. So in the positive number category, I can try, hey, equals to 1. What does that equal to? Equals to 1, okay? If this equals to 2 to the power 3 is 8, and cubic root of 8 is going to be 2. And if this is 5, right? And then 5 to the 5 is powered by 3 is 125. And that's going to be 5, right? So this is true. It's true for positive number. Is it true for 0? It's true for 0. Is it true for negative, right? Is it true for negative? Suppose I have -1, x is -1. Is it true? Okay, and this is going to be cubic root, right? On -1 times -1 times -1, order of operation, right? And then you get cubic root of -1. -1 times itself 3 times is still -1. And the cubic root of -1 is -1, right? So if you remove everything in between, and you keep trying different numbers, you try 2, this is going to be -2, you try 3, and that's going to be -27. Cubic root of -27 is -3. So these are true for any real numbers. Therefore, 3 is true. 3 is true. Okay, now let's look at number 4. Let's look at number 4. So what's on number 4? Number 4 is an interesting one. Okay, number 4 is an interesting one. So let me show you number 4. Okay, This is number 4. Number 4, we have the inverse function, right? The inverse function. Hold on. I'm going to write down the question, right? It says the inverse function. The inverse function for, okay, f of x equals to x squared, where x is less than 0, is f inverse of x equals to square root of x. Okay, with domain x is positive. All right, okay, so let's go back. Let's go back. There. Okay, so that's the question. Is it true or false, right? It was asking, is it true or false? Okay. Now, is it true or false? Right? Is it true or false? We know that f of x equals to x squared, right? When x is less than 0, right? So if you draw the curve, are they symmetrical along the green broken line? Remember that green broken line, right? So what I meant is that y equals to 0, right? I'm going to start the rectangular system. So this is the way you can check very quickly if you're familiar with the graph. If we are familiar with the graph. Okay. So I'm going to have, say, less than 0. And I'm going to plot the curve. Right? So let's see how we're going to plot the curve. The first one, the function given says x is less than 0. That's why we show the negative sides of x, right? X is less than 0 for, oops, x squared. I'm sorry, this is x, should be x squared, my bad. Okay, x squared. X squared, so it's this piece, right? So we're gonna graph that piece. We're gonna graph that piece. Okay, x squared. So we get that piece of function. Okay, and let me make some adjustments so that it looks better. Okay, so that's the function, right? Hold on. Oh, x, I can make it like 5, right? Y, oh, 0.01. This will make it look better. Okay, so that's the piece of curve, right? So now, how about the other function? The other function, y equals to, I'm gonna graph, whoopsie. Okay, I'm gonna graph the other function. Okay, square root of x. So I'm gonna graph this function right there. Okay, right there. Plot it. Okay, and the view is, that should be decent, right? So I'm just going to put them next to each other, right? This is square root of x. And I'll make their scales comparable. Okay, I make their scales comparable, or I can graph it on the same picture. Okay, so let me do that. So this might be easier. Okay, it's just like it's well, I have to do some cutting. Okay, now I'm going to graph square root of x. Okay, and I also have to make these adjustments. Okay, this piece has to be gone. Okay, so this piece has to be gone. Okay, so I'm gonna erase that. Okay, this piece is gone. This piece is gone. Okay, that piece is gone. If these two functions are inverse to each other, okay, they should be, oh, never mind. I'm going to make some adjustment. Okay, I want you to see better. Okay, just hold on. I'm going to just put one more thing there. Okay, that broken green line. Okay, and I know this is a little, I have to coordinate these two functions, right? And hold on, this piece has to be erased. Okay, and I'm going to make it nicer. +3, maybe just 4. Okay, this piece make it 4. Okay, so next I make these two comparable, right? So we can scale the picture, right? We know there's this line is the line of symmetry for any two one-to-one function that are inverse to each other. And right now I need to erase this piece. Okay, I need to erase, wait. There. No, just this way. Okay, so I'm just going to get rid of this piece because I will explain to you why. Because x squared only have the piece for x less than 0. Okay, x less than 0. Okay, so that's the curve we're getting. These two, if these two were inverse to each other, they should be symmetrical along this green broken line. Are they symmetrical along that line? Of course not. They're not, right? They're not symmetrical. So from here, we can already tell. Okay, I'm gonna write it down here. Okay. F of x equals to x squared, where x is negative, and the other function square root of x are where x is greater than 0, right? X is larger than 0, okay? All the condition we were given, right, are not inverse function to each other because no symmetry. Okay, no symmetry about, okay, no symmetry at y equals to x. Look at this. No symmetry above the line y equals to x. There's no symmetry. Okay, so let me do this. So now we can see them all, right? There's no symmetry. Therefore, because as we said, any one-to-one function and its inverse must be symmetrical about y equals to x, that broken green line. We've been using this forever, right? Since the beginning. So we will be consistent with it. Therefore, they're not inverse to each other. They're not inverse to each other, okay? So for this question, we already have the answer. We already have these answers. Now the question is, what is the inverse for that function, right? So I'm going to go over that with you, okay? I'm going to go over that with you as well. So pretty much the answer is already given to you. So next I'm going to just clean up, right? And just allow me to, so number 4 is answered. Number 4 is answered, it's false. Okay, number 4 is false. Now the question is, if we go further, right? What is the inverse for it? Right? So this is not the inverse. What is the inverse? Okay. This is actually your homework question. What is the inverse for this function? What is the inverse for that function? Right? All right. Let's go. Obviously, this function is 1-to-1. Okay, so first we're going to say that f of x is 1-to-1. Oops. Is 1-to-1. Okay, we understand that, right? It's on the left part of parabola. On the left part of parabola. Okay, it's left part of parabola. So this is a 1-to-1 function, and thus it has a unique inverse. Okay, so we're going to call it F inverse. We don't know what it is yet. Okay, we're going to call it F inverse. Okay, so let's find it. How do we find inverse? We're going to bring the function in the state as y equals to x squared. The domain, domain for x is less than 0. How about y? Well, if x is negative, x times x will be positive. So y will be positive, right? And so we're going to get to our step 1. Step 1. Step 1, swap xy. Swap xy. Okay. Swapping xy, what do we get? We got x equals to y squared. And this swap has great significance. Okay. What is it? Because domain and range will also be swapped. Okay, domain and range will also be swapped. Now, if x is less than 0, now what? Now y is less than 0, right? Because x becomes y. It used to be y is larger than 0. Now y turning into x, therefore x is larger than 0, right? So there's a swap. Okay, with that swap, we're solving step 2. We're solving for x, solving for y. We're solving for y. When we're solving for y, right? Obviously, we're going to take square root on both sides, right? That seemed to be rather obvious, right? Can we take square root? Well, both sides are non-negative, right? X is larger than 0. Y squared is larger than 0, right? No problem. So we can take square root. And the left-hand side, right? Left-hand side, we still have square root of x, right? X is positive. X is positive. How about y? How about the square root of y squared? How about, what is it? is going to be absolute value of y, right? Understand that y is negative, x is positive. So these continue to tag along. Okay, consistency. Now the question, we want to solve for y, but y is not isolated yet. How do we isolate y when y is negative? Okay, since y is negative, okay, the absolute value of a negative number, okay, recall that narrative. I'm going to write it down over here. The absolute value of a negative number is its opposite. Is its opposite. Okay, we have talked about this in the first week about absolute value function. Okay, the two branches we talk about. Okay. So the absolute value, what does that mean? It just means that when y is negative, since y is negative, the absolute value of y is going to be equals to the opposite of y. Y itself is negative. Okay, I really ask you guys, if you have issues here, okay, you really need to get over this. Please go back to see these lessons. Okay, to see these lessons. Absolute value function right here. I spent about 40 minutes explaining and these two lessons. Okay, these two lessons, did you really understand them? Very important. I couldn't emphasize it enough. Okay, lots of mistakes have been made. It determines 10, 20, at least 20 points for your future pre-calculus class and your calculus classes. I mean, plural calculus classes, not just Calc 1, Calc 2, Calc 3. Okay, this absolute value function, it's omnipresent. It's omnipresent. I have no idea why, I have some idea why it's omnipresent, because this function is very, very important. Okay, you don't know how many students lost points because of these, because of the lack of understanding of it. Okay, because of lack of understanding of it. Okay, so anyway, so let's go back to our situation here. So now, as a result, this whole thing will turn into, this will equals to negative y, right? So we end up with square root of x, right, equals to negative y. And then then we know how to isolate y, right? Now y is negative square root of x. This is really your homework question. Okay, this is really your homework question. Okay. These issues actually brought to my attention that I still want to remind you guys, really, please watch the lectures. Please watch the lectures. If you don't plan to watch the lecture, you really are wasting your time taking this class. I thought you would take this class because you want to listen to what the instructor has to say. If you think you can do it all by yourself, why don't you just take calculus straight, right? Just go ahead, take calculus. Okay, no one can stop you. I don't think so, as far as I know, right? But anyway, we found our inverse. And what's our inverse? Finally, our inverse is this guy. Our inverse is negative of square root of x. That's the difference. That's the difference. Okay, where x is positive. Where x is positive. So now let's look at the graph. Let's look at the graph, right? F of x. This is f of x, right? Where's our f of x? F of x is here, right? We know this is not the inverse. So f of x is here. Its inverse is this guy. It's inverse. Let's look from the graph. Right, we're gonna graph them in the same picture. Okay. Okay, so we're gonna graph these two pictures together. Okay, we're gonna graph these two pictures together. There we go. We still have to do some adjustment. Okay, so allow me. And you can do it alongside with me. And the next function is square root of x with a negative sign in front of it. Let's see if they're inverse to each other. Okay, so I'm gonna choose the red color for the other one. Okay, and in this picture, we have to make some adjustment because the software doesn't do the job we tell it to do. Okay, so from -3, maybe from -5 to 5. And this is a -5 to 5. And also I'm going to graph the green line. Okay, that broken green line. And what needs to be adjusted, right? We're gonna make sure it's the units are comparable. Okay, and also we need to erase this piece. Why we need to erase this piece? Because x squared, when x is less than 0, it is not this, it's just the piece on the left. Okay, so that's why we need to erase this piece. Okay, they are symmetrical about y equals to x, aren't they? So they're inverse to each other. They're inverse to each other. Of course, we already know it. We already know it. Okay, and I could have adjusted the one unit a little bit shorter, but there are. This is the inverse to each other. From the graph, we can decide, yes, they are inverse function to each other. All right. So in the process, let's recap what we have done. Okay, the absolute value of a negative number is its opposite. Okay, I just wrote down. You can go back to watch the lectures and watch what's in the first week. Super important. You need these, you need to speak this language fluently with complete understanding. Okay, that's how you're going to get those points. You are going to be applying these principles, applying these, observations to your calculus classes questions. Okay, to your calculus class questions. Okay, so if you have further questions, please don't hesitate. Please don't hesitate. Do watch the lectures. Please do your homework. If you have any questions, please come to my office hours or to tutor's office hours to get help. Okay, now So let's see, next question. Okay, quiz number 5. The next question. Next question. So we did number 4, number 5. What do you think number 5? What do you think about number 5? Yeah. Number 5 is it true or false? Number 5. Right? Those questions are 4 plus h in the root minus 2. 4 plus h minus 2. Right? And the other one is 4 minus h plus 2. 4 minus h plus 2. It goes minus 2. Are they conjugate to each other? 4 minus h plus 2. Okay, let me just make sure I copy the question correctly. Yes, I did. Okay, so let's share that. Okay. Are they conjugates to each other? Okay. Are they conjugate to each other? Well, if they are conjugate, right, we will know that the conjugates A plus B times A minus B would equals to A squared minus B squared. The question is, which one is A, which one is B? If we decide square root of 4 plus h is A, square root of 4 minus h cannot be A because they're different. Minus 2 plus 2, that can be 2 can be the B, but obviously these two are not the same. Therefore, they are not conjugate. Okay, the answer is no. They are not conjugates. They're not conjugates. Okay, so that it has to be, you have to determine which one is your A, which one is your B. Okay, so let's look at the next question, number 6. Is x cubed plus x an even function? Okay, is x cubed plus x an even function? The answer is false, right? How do we do that? How do we do that? Okay. So let me go back. Number 6. F of x, this is your homework question, isn't it? X raised to the power 3 plus x. Is it even? It is an even function. Right? How do we determine if it's even or odd? We have f here, and we just have to work out the negative f of a negative x, right? So when x is replaced by negative x, what do we get? Right? We'll get a negative x to the power 3 minus x. Apparently, f of x is not the same as f of a negative x. That's the definition of even function if this were equal. right? If this were equal, but they're not equal, right? Therefore, it is not. So this is a false. Okay, it is not an even function. Okay, that's pretty straightforward to answer. In fact, it's an odd function. It's an odd function. Okay, so in fact, of course, we didn't ask you that many questions, right? In fact, it is an odd function. Why? It is an odd function, right? But we didn't ask you for that. So for odd function, you basically need to compare these two, right? One is f of negative x, the other one is negative of f of x, right? Negative of f of x. So we put a negative sign in front of the entire function. So you put a negative sign in front of it. And what do we get? We get exactly the same, right? We distribute a negative sign to it. So when these two are the same, right? They are the same. Okay, so it is an odd function. It is an odd function. It's an odd function, right? You can say because the following reason. Number seven. Okay, let's see what's number 7. Number 7 says this is an even function. Is that true or false? This is a homework question. This is a homework question, isn't it? Okay, so the function we're dealing with is it's just a little bit different from the previous one. Instead of x raised to the power 3, and we have x squared. Is that even function? Right? It's asking, is that even function? So it's the statement says f of x squared plus x is an even function. Is an even function. Okay, is it true? Right? Is it true? All right. Is it true? Well, all we have to do is go by definition. Okay, all we have to do is go by definition. We have f of x here, and we just have to figure out what is f of a negative x, right? So negative x replaces x, and then we end up with what? Negative x times, the negative x squared is negative x times negative x, plus negative x is minus x, right? Negative x is negative x times negative x is x squared. So minus x. Are these two the same? They're not, right? One is, they both have x squared, but they don't have, one has a plus x, the other one is subtract x. Therefore, right, because f of x is not the same as f of a negative x. Okay. It is not an even function. Okay. And you're done with this question. It's not an even. However, this is a homework question, right? In homework question, we ask you, is it even, is it odd? Is it neither, right? There's 3 categories you have to put this in, right? Well, in fact, if you want to discuss further, right? So we know f of x is this, f of negative x is this guy, right? We already have that. And it's not even, maybe it's odd, right? So we're gonna put negative sign in front of the, by definition, right? Put it in front of the entire x. We put a negative sign in front of it. And what we get is that we get negative x squared minus x. Okay, so if these two are the same, okay, if these two are the same, then it's odd. Are they the same? Apparently not, because x squared minus x, the other one is a negative x squared minus x, right? So there's a difference. There's a negative sign here, but no negative sign there, okay? So you say because f of negative x is not the same as negative of f of x, which is contrary to the definition of odd function, right? Then this is not, okay, is not odd either. Okay, so the conclusion that this function is neither even nor odd. A footnote. Some people confuse with these two. Okay, some people confuse that negative x squared with negative x squared. These two is different. Okay, these two are different. What's the difference? A footnote. What's the difference? The difference is negative x squared. Okay, the negative sign is outside, so we have to do exponents first. So we're going to do x times x first. The negative sign tags along. Okay, and this other one, however, negative x in parentheses squared. This means that the parentheses time itself. So these two are very different. These two are very different. Okay, so the latter equals to x squared. Okay, so now let's look at other questions. Okay, number 8, we have 2 more to go. Okay, we have 2 more to go. Okay, the inverse function for f of x equals to 1 over x plus 3 is f inverse x equals negative 3 over x with domain x is not equal to 0. Okay, true or false? True or false? Okay, there are multiple ways to approach this. Okay, so this is number 8. These are from homework. Okay, the inverse function for f of x, okay, so I'm copying this question, equals to 1 over x plus 3 with domain x not equals to negative 3, right? We examined that, is f of x equals to negative 3 over x with domain x is not equal to 0. X is not equal to 0. Okay, so let's look at this question. Let's look at this question. Is that true or false, right? Yeah, true or false? Well, it seems that domain makes sense, right? The domain makes sense. The domain is not proper. Okay, so there are multiple ways to do this. I'm going to do this way that, probably most straightforward way. Okay, this is probably most forward way. So we already kind of were told this is a one-to-one function, right? And it does pass, if you graph it, it passes horizontal line test, right? It passes horizontal line test, so that's not a problem. So we can go straight to find inverse, okay? Domain, okay? We're given the domain, x is not equals to -3, and the y cannot be equals to 0, right? And step 1, swap xy. Okay, swapping xy. The consequence of this swap is x equals to 1 over y plus 3. Okay, we know this. We know the significance of this swap, right? It also caused, it used to be x not equals to -3. Now x turned to y, so y cannot be equals to -3, and x cannot be what? X cannot be 0. It's just a swap, right? So these is just the swap of symbols and the swap of domain and range. Always. Okay, you're gonna see this pattern in the future for future functions as well. As we have seen, we have studied exponential or logarithm functions, right? Same thing, the same property, okay, same property, just different rules. Okay, solve for y, solving for y, right? Solving for y. How do we solve for y from here? That should be pretty straightforward, right? We're solving for y. We're going to isolate y, right? We're going to isolate y. So we can see the left-hand side as x over 1. So we flip both sides. Right? So 1 over x is going to be equals to y plus 3, right? Y plus 3 plus 1. Okay? The same as y plus 3. Okay? And then what? Subtract 3 on both sides. So y equals to 1 over x minus 3. That's our inverse function. Is it the same as this guy? Of course not. Of course not. So that's a false statement. It's a false statement. So F inverse right, is going to be equals to 1 over x minus 3. The domain is set correctly. The domain is x cannot be 0. Okay, so that part is correct. But this statement in general is false. That's number 8. That's number 8. Okay, so let's look at number 9, the last question. Okay, so I think I'm just going to copy that question, right? Actually, there are several statements in that question. Okay, I'm going to copy the whole. And that's your homework question as well, I believe. Okay, so this is a multiple choice questions. You're given, you're going to pick up all the correct answers. Okay, so we're given a function. We're given a function, and this function is x plus 2 to the power 3. Okay, and we have multiple statement. The statement A says f is 1 to 1. Is 1 to 1 function because x sub 1 plus 2 to the power 3 is different from x sub 2 plus 1 to the power 3. So different input produces different output. And is that true? Say one ever, right? One ever. This is a quoting the definition as it applies to this specific function, right? Is that true? B, the domain of f is all real numbers. The domain of f is all real numbers. It's all real numbers. Okay. C, the range of f is all positive numbers. The range of f is all positive numbers. Okay. D, there is a unique inverse function. And that inverse function is f inverse of x equals to the cubic root of x minus 2. E, they're still saying there's unique inverse function, and this time the inverse function given is cubic root of x plus 2. Okay, so let's see which one is right. Apparently when x1 and x2 are not the same, that the first statement is right. Okay, so correct. The correct ones are A. Okay, how about B? Domain of f is all real numbers. That's true. B is true. Okay, C, the range of f are all negative numbers. That's not necessarily true, right? So C, why C is not true? Well, if x is equals to, say, -3, right? F of -3, it would be equals to what? You plug in -3, right? And that's -1 to the power 3. And that's negative, right? So the function value is not necessarily a positive number. It could be negative, okay? So C is incorrect. Okay, let's see what else. D, there's a unique, so the D and E is about inverse, right? So let's find the inverse. So how do we find inverse? Let's find the inverse. The same old trick. Okay, you can graph to see if they're symmetrical about the green line. Okay, here I'm just going to I'm going to straight to it. Okay, so I have y here, right? Domain is all real numbers, right? All real numbers. So x is going to be from all real numbers. Domain and range. Okay, and y belongs to all real numbers. So you can look at the graph, right? Horizontally, it can go as far as possible. Vertically, it can go as far as possible. So step 1, right? Swap xy. swap XY. Okay, so right here, we're gonna swap. X becomes Y, Y becomes X. Right, so this becomes X and this becomes Y. Okay, and solve for Y. Step 2, solve for Y. Solve for Y. Right? So when we try to solve for Y, of course, this swap produces the same, well, the domain and range are the same. So when we swap it, they're still the same, right? So that swap still takes place. It just, they end up to be the same, right? So that's a part we don't have to worry. So then I'm gonna take a cubic root on both sides. Cubic root. Okay. The right-hand side. Whoopsie. The left-hand side stays as it is. And the right-hand side is just Y plus 2, right? We see this before. And next, you subtract 2 on both sides, right? So in the end, we get Y equals to cubic root of X minus 2. So if you look at D and E, none of them, right? So D and E, none of them. So if you look at the D and E, the answer given in D and E, if you compare with the true inverse we have here, right? F inverse, they're not the same, right? So none of them is correct. So that equals to this function and the domain is all real numbers. Your homework question being asked on the quiz. Okay, so what is the right answer? So incorrect, D, E. Okay, so the final correct answer is A and B. A and B. Okay, so that concluded quiz number 5. I hope you guys did well, but I certainly got questions. And these questions seem to tell me that you guys need to work harder on your homework and watch the lectures. Okay. And if you have any more questions, please don't hesitate to reach out to me. I'll be happy to answer your question. Thank you for watching. Until next time.